Hey guys, we're going to start section 6.6 here, which is on solving exponential and logarithmic equations. This is actually a pretty long section, so it's going to get split up over several videos. First up, we want to look at exponential equations, and specifically exponential equations where you only have a single exponential. So let's look at this one. This is about the easiest type of equation there is in this section. We've got 2 to the 3x minus 1 equals 32. Now, on this equation, 32, you might recognize 32 is 2 to the 5th. And if you know that, you get 2 to the 3x minus 1 is equal to 2 to the 5. Well, if those two numbers are the same, since they've got the same base, that's going to give you that 3x minus 1 is equal to 5. So that gives you 3x is 6, so x is 2. Now, that worked out nicely, and we just kind of lucked out on this one really because 32 happens to be a nice power of 2. But what if it weren't? Or what if it were a power of 2 but you didn't recognize that? How would you go about doing this? Well, the other thing you could do is you could take the log of both sides. I'm going to take log base 2 of 2 to the 3x minus 1 equals log base 2 of 32. All right. What we know by the, we have the rule that says if you take log base b of b to something, the log and the exponential undo each other and you just get that something back. So that gives you 3x minus 1 equals log base 2 of 32. And if you didn't know what that was, you could do this on a calculator by doing ln of 32 over ln of 2. Some calculators also do can do a base 2 logarithm, but I'm not going to do that. If you put that in the calculator, it would give you 5, and then this would also give you x equals 2. So let's look at the general way to deal with these types of things. When you're solving an exponential equation and the base is b, what you want to do is first isolate the exponential to one side, and you want to be sure that it has a coefficient of 1. Then once you've got that, you take the base b log of both sides to eliminate the exponent. And this method is good, but it's good when the numbers are nice, but it kind of sucks when the base is ugly or if the other side is, I didn't finish writing that out. It's bad if the base is ugly or if the other side is not a nice number. So let's look at this one. Solve 3 times 5 to the x plus 4 equals 637. All right, so let's see. 3 times 5 to the x, take the 4 off of both sides, 633. Divide both sides by 3, you get 5x is 211. And then you take the log base 5 of both sides. So log base 5 of 5 to the x equals log base 5 of 211. And this over here becomes just x. And the other side is log base 5 of 211. Well, that's the exact answer, but it's probably not the answer you want. I mean, you'd like to have a number. So let's get this as a decimal approximation. And I'm going to do that as ln of 211 over ln of 5. I'm going to do that on my calculator. So let's see, ln of 211 divided by ln of 5. Now on this, it's important that you get your parentheses correct. The calculator puts in, when I press ln, it puts in that first parenthesis, but it doesn't put in the last one. It's important to put it in there so you got ln of 211, close parentheses, then divided by ln of 5. And when I hit enter, that gives me this number, 3.325, etc. I'm just going to put some dots there. I guess I should switch back to here. All right, so that's my answer. All right, let's do this one. We've got 10 to the x over 3 plus 11 equals 1, 2, 3, 4. All right, so Let's take 11 off of both sides. So we've got 10 to the x over 3 equals 1, 2, 3, 4 minus 11 is going to be 1, 2, 2, 3. Now I got to multiply both sides by 3. Let's see, 1, 2, 2, 3 times 3. That's 3669. I guess I could have done that in my head, but I didn't. Now take the base 10 log of both sides of this. So you just get x is log 3669. Remember, if it's base 10 log, you don't have to write the, you don't have to put the base in there. So my calculator will give me this log of 3669. Now before I do this, let's think about it. Log of 1,000 is 3. Log of 10,000 is 4. So I know that this is going to give me an answer that's going to be 3 point something. And it's going to be closer to 3 than 4. Why? Because 3669 is closer to 1,000 than it is to 10,000. Okay, I was wrong. I get 3.564, etc. Oh, 3669. Anyway, well, we knew it was going to be between 3 and 4, and sure enough, it is 3 point something. Okay, let's look at this problem. 100 times 1.01 to the 10t equals 250. This looks a lot like a problem that might have, or an equation that might have arisen through an interest problem. But let's solve this. So first up, divide both sides by 100. And then you get, this will be 1.01 to the 10t equals 25 over 100. You can divide both of those by 50 and you get 5 over 2. All right. Tell you what, let's, instead of writing it as 5 over 2, let's write it as 2.5. Keep everything in terms of decimals here, not that it matters. And now we want to take the log of both sides. Now, which base will we use? Well, we use base 1.01. That seems a little unwieldy, but it'll work. So I'll do log 1.01 of 1.01 to the 10t equals log of 1.01 of 2.5. I said that wrong. Log base 1.01 of 2.5. All right, so this gives me 10t equals log of, or log base 1.01 2.5. So t is 1/10 log of log base 1.01 of 2.5. And if we want to get a nice decimal answer for this, we need to rewrite this using the change of base formula. So the log is going to be, let's make it ln of 2.5 over ln of 1.01. And this 1/10, the 10 is going to be in the numerator. So for my calculator, what I'm going to do is put in natural log of 2.5 divided by, I've got to put an open parenthesis here, 10 times ln of 1.01. Now this is how I've got this put into my calculator here. Notice I've got an extra set of parentheses around the 10 natural log 1.01. That gives me an answer of 9.208. Now, what if I didn't put those parentheses in there? I'm honestly not sure if it's going to give me the right answer or not. If I leave those parentheses off, it's saying natural log of 2.5 divided by 10. I'm not sure if it's going to multiply by the natural log of 1.01 or if it's going to divide by it. Yeah, notice it gives me a different answer. So on this, let's see, what you need to do is put that entire denominator in parentheses. All right, so our answer was 9.2086, like that. All right, we can actually skip some of these steps in here by using this next method. Um, the next method says it's method 2 for solving the same type of equation. You isolate the exponential to one side, make sure it has a coefficient of 1. Then you take the ln of both sides and use the power rule. But we'll save the examples of that for the next video.